కాదు కిరణ్ చేయలేదా అయితే?
Yeah, yeah. Hello, good evening, all. I'm Swapnil. I'm a PhD PMRF scholar at CSE department, IIT Jodhpur. So, so for this course, data mining, I'm taking the live session for this course. So, further 8 weeks. For each week, we will take a live session on Friday, 6 to 7 p.m. Yeah. So in this live session, our motive is to discuss your doubts, and ultimately, I'm taking some questions which are related to a respective week. So that will be helpful to understand the concepts that has been taught in that particular week, which will be helpful to understand. And also, you will help, that will be help solve the assignment that is assigned to each week. Okay. So if you have any doubts regarding this week, you can ask me in this session, as well as in between the week. If you have any doubts, you can write me an mail. I will share my email ID with you. Okay. So yeah, and so this session will be recorded and will be available to you. But this will be uploaded to the YouTube, so you will get an in YouTube link to this swam website actually. Okay, in that particular course. Okay, in this particular course. Also, the material I'm using here, that is in suppose slides or any script, Python script or any script. So that also make available to you through this website as well. Okay. Yeah. So many students are still joining, so that's why I'm waiting 1 second. Let me share my screen. Yeah. So many students had joined now. So I will introduce myself again. So I'm a Swapnil Mane. I'm doing a PhD at CSE department, IIT Jodhpur. So I'm taking this live session for this course, data mining. Yeah, we'll start this session. Okay. Uh, yeah. So this is my mail ID. You can mail me here if you have any doubts in between the weeks. Okay. Yeah. So I hope you guys understood the whatever has been content taught in this week. And in this week, let's take as a summary of this week what exactly we have learned in this week. So, so we have learned what is the necessity of the data mining, right? So that will be helpful for any applications which will be, let's take as an in healthcare or any e-commerce website or for e-commerce data. So this data mining concept can be utilized in the various domains. Okay. No, just we have started this session, Shreya. So there is no has been missed yet. Okay. Hmm. So in this week, we have also studied what exactly the data mining is, right? So we have Dr. Pavitra has already that seconds. Still, students are joining. Yeah. So the what exactly the data mining we have studied, which is an the data mining is nothing but is an knowledge discovery, right? We have to find or we have to explore the patterns which are non-trivial, which is are not simply you will get from the data, right? These are the patterns are hidden from the in the large data, right? So which is an extraction of the interesting or important patterns from the data, from the huge amount of the data, and those patterns are mostly implicit or it is an non-trivial as well, right? So this is an data mining, right? And the data mining that is an the knowledge discovery we are calling, right? We are discovering a knowledge from the huge data, right? And this knowledge or that knowledge we are calling as a pattern as well. So these patterns are novel, this is are not trivial patterns, right? So I will give us some examples that will help to understand these concepts easily, right? Okay. So as might be some students or some people might think that the data mining might be one case, that suppose you have a relational database, and in that relational database, if you want a relevant data, you might be a query, you might be given a query or injecting a query in the database, and you will get a relevant database, relevant data, right? So that is not exactly the data mining is actually, right? So only getting or getting a relevant data from the database is a one of the a step to get a to do a data mining actually. So as we have seen that the data mining has an obeys or is it works on the KDD process. KDD means that is a knowledge discovery in the database, right? The data by mining that already said that we can say that we are discovering a knowledge, discovering the knowledge in the database, from the database, right? So in that KDD process, we have seen that multiple steps, right? So what exactly the multiple steps are there? As we know that the data in the current scenario in our internet, the on social media, let's take it on social media, the growth of the data is tremendous, right? You can imagine that how much users are posting their post, Instagram post or Facebook post or tweets, right? And in 1 minute or 1 seconds, how much the posts are getting growing over the period of time. Also you can see the YouTube videos also, uh, the data is also growing, right? In 1 minute or 1 second, the videos, multiple videos are uploading the users on the uh, YouTube. So this data is not stored in a single point of source, right? The data is stored in multiple sources, multiple uh, locations, that we are calling as an distributed database, right? So this is the one step to retrieve the relevant data. Suppose we wanted to do a task, that is a clustering task, to find a patterns, means let's take as an one example, that is an suppose you have a lot of data and you have to suppose let's take as an passenger data, train passenger data sets, right? So if you wanted to find the passengers who are from that particular region, region A, region B, and region 2, region 3, right? So each passenger, you have multiple attributes, multiple characteristics of the each passengers. So what is the age of that passenger? What is the from which location he is coming from, right? What is the nationality of that particular passenger, right? So using this passenger, we have to identify which are the passengers from this particular region A, region 2. So we have to build uh, a mathematical model such that it will gives directly that particular passenger is from the region A. So this all the findings we are getting, or all the knowledge or patterns we are getting, or we are finding, it's from the historical data, right? So this is the one concept, this is the one example that I have explained about the uh, knowledge discovery, and or we can say the data mining, right? So this is a passenger data. There are a lot of passengers data there. There is flight passenger data is there. There is an bus passenger data. There is a train passenger. If you want to only get the patterns from the train data, then you have to only retrieve the train data, right? So that is a retrieval step. Actually, we have to retrieve the from the distributed database, uh, from the distributed data set, and retrieve the data into a data warehouse, one single data source, right? Right, data we are maintaining at the data warehouse, right, to get the patterns, or that is relevant data for our task, right? Then we have to do a pre-processing. In the data pre-processing, we have seen many things, so such as an what is exactly the data is, right? That is a collection of the raw data, right? That is a knowledgeable data, we can see that. And the data has been, that Dr. Pavitra has mentioned that what data has represented, which is an in objects and in the attributes. What are objects and attributes? Let's take as in one table. So this is in one relational table. Let's assume that. So objects represents, in this table there are two components are there. What are those components? Which are there are rows are there in the table, right? And there are columns are there in the table, right? So this row, each row represents an objects. This is an object 1, object 2, object 3, likewise. And each object has in their attributes. Attribute 1, attributes or characteristics. Attribute 1, attribute 2, attribute 3, such attribute for likewise. Let's take one example. Let's in this table, let's map the another example, which is, and suppose the object represents and multiple cars are there, right? So the car models, let's take as an Alto car, or there is an BMW or Baleno cars are there, right? So here is an Alto, Baleno, right? These are the car names are there. These are objects are represented, and for each car there is an characteristics of each car, right? What is the color of that particular car? That is one attribute. What is the mileage of that, what is the mileage of that particular car? That is another attribute. What is an that car is an based on which uh, uh, source, which is an, that is an, it is from an, it is based on the petrol, it is based on the diesel, or it is based on the CNG, right? Or both, right? So these are the another attribute. Another attribute might be it is an auto geared, or it is an manual geared, right? These are the multiple attributes. So this is an one example that we can say this represented as one data, right? So here might be you have understood what exactly the objects are there, and what are the attributes are there. So the querying the database, you are only retrieving data that you want actually. Suppose if you wanted, there are the passenger, let's take as a passenger data. So you have a database, and there is a lot of passengers data is there, right? So from this data, you are only retrieving, if you wanted a data of users or passenger who has age in between the 25 to 30. So you are only doing, you writing a query, and you will get that is a query represented an age in between the 25 to 30, right? So you will get only that particular users. You are not getting any patterns or any knowledge. You are not discovering any knowledge from that particular data. You are only retrieving that data. uh, Guys, are you, am I audible to you? Someone has written that I'm not audible.
No, audible, sir. You are audible.
So yeah, not able to hear. Okay. Might be you have understood what exactly the difference between the querying the database and the data mining technique. In the data mining techniques, what exactly we are doing? Suppose we have a data, we have a passenger data, and we are finding. Let's take another example that related to the data mining techniques. Okay, so that is my also I'm working my PhD also. I'm doing in that particular topic, which is, and once we have a social media data, right? And as we know that yeah, Tripati, yeah, okay, that may be mistaken. uh, 1 second, some students are still joining. Let me add them. Hmm. So uh, let's take one example. So that is my part of PhD work that I'm doing here, and let's map that particular example in the data mining technique, how that can be that is workable. And yeah, you want to say something? Okay. So as we know that in our real life, suppose my friends, okay, my directed friends means what my best friends are buying iPhone, okay, and I'm using a Samsung mobile or any Vivo mobile or anything, right, other than the iPhone. So all my means my most of the friends, best friends, are buying the iPhone. So in that case, I'm also feels like that I also wanted to buy a iPhone, right? This is a obvious feeling, right? So in the social media, so is it true this phenomena that we have discussed right now? This phenomena is also true in the social media case. So whatever the feeds we are watching, those feeds, suppose that those feeds are influencing to you or not. Means let's talk in specific way. Suppose those feeds that are you are watching, that feeds means your friends, your following users are posting something that you are watching, right? So those feeds, suppose so related to some events. So watching those repetitive events, and most of the your friends are posting those relevant related to events that their opinion, is it possible or is it true that your posting behavior also tends to their to your feeds or not? Is your posts are related to your feeds post or not, right? So these patterns, these findings, that this knowledge is not directly visible. Directly you are getting from the retrieving the data, right? You have to design a model, mathematical model, to fetch the user data as well. That is one part of fetching is, and retrieving is a part of the data mining process, right? So you have to get a user data and their feeds data, and you have to design a model such that, so what is the impact of the particular feeds on the users post, and how the users are influencing, that you have to build a model, so that you will get a pattern, so that you will get a knowledge from this historical data. So this is a one way, this is one application that can be used, that can be use of a data mining technique, right? Deep, you wanted to say something, you have raised your hand. Okay. So might be you have right now distinguished that what exactly the data retrieving, that is, and querying on the database, and what exactly the data mining is, right? Finding a patterns, finding a novel patterns from the data, from the historical data, large data. Okay, so this is a basic concept that you have to remember that. So yeah, we have in the data pre-processing, we have seen multiple types of attributes. That is, an nominal attribute, ordinal attributes are there, or interval attributes, or ratio attributes. Nominals, that is an identifier, that is a name or any identifier. It's not comparable in between them, right? And ordinal, those, let's take as an one example that also Dr. Babitra has taken that same example, which is an the ratings of the products. You have a multiple products, and each product there is an ratings. those ratings are comparable, right? This product rating is greater than this product, right? So that is an ordinal data type. Internal data type, let's take as in that particular product has an that date has been mentioned. So in this period, the 26th of the January, there is an best offer for this product. Likewise, okay, 25th to 26th January, there is an best offer or offers for this particular products. So this is an interval data type. Another is an ratio data type, which is an free values. So these are the what is the exactly cost of that particular product. Likewise, okay. So the yeah, we have seen the attribute types, and in the data type we have seen that suppose this table data is there, then that is an record data type. Suppose there is an graphical data that have we have discussed currently, that is an that users are there and their feeds means their best friends or their following users post, right? So how it's not independently you have to consider, you have to map into a graphical structure. So this user is following to multiple users, also their following users are following to multiple users. So you are constructing a graph. So this is an one graphical data type, graph data and data type, right? So another example is an friendship data type. So this is an the previously example I have explained, that is an following graph structure. Actually, the users are there and the relationship is an following. This user is following to this user. Likewise, another is an friendship, right? So the friendship network is there in the Facebook, considering. Or another example, let's take as an Twitter. If there is an Twitter example, there is, let's take as a retweet. This tweet is retweeted by this user. Likewise, so this is an graphical data type. Another is an ordinal data type, right? So in that the order is maintained, means this object one,
Yeah.
yeah. So the object one will be, one second, the object one will be incident before the object two. It's not as an object one and object two is shuffled, it's not possible. So when it is occurred, right, when if it is a time series data, right, if the t1 time the data is occurred like this way. So in t1, the suppose this user has make their friends, 5 friends they have. In t2 he has done a 2 friends. So this t1 and t2 it can't be shuffled, right? Right, this is an ordinal data type. One example that have again. So there is a noises are there, multiple missing values are there maybe. Okay. So that you have to handle how we are handling that data. We need to normalize the users, or we can list we can mean of that particular column. Based on that we can feel that noise, or we can remove those objects who has present a noise. So this is a way you can handle a noise. Actually there are multiple uh, ways to do a data pre-processing, right? So after that we have seen the multiple data pre-processing steps, which is and data aggregation, sampling, then dimensionality reduction, feature subset selection. Then we can suppose we have a continuous values, then we can convert it into the binary values as well. So let's take as an the previous example, which is an passenger example. If you have age of that particular passengers, then you can, this is an continuous values, right? So 1 2, these are where ages are there, 23 25 35. So you can give a range, that is, and suppose 1 to 14 age, then you can give a category A, like this. Or this is an uh, give a district value, which is an, these are youngest users, youngest passenger. Or this is an, another is an adult passenger, the 14 to 18 to 25. Likewise, okay. So this is, you can convert it into the binary or the districtization, we can say that, okay. Then attribute transformation, so you can transform the attribute from another domain. Suppose you have multiple attributes, suppose attribute A and attribute B, and using this attribute A and attribute B, you are creating another attribute D. Okay, likewise. Yeah, so this is an pre-processing we have seen. This is an overview we have discussed here. Okay. Another is, and after that, so after this deep data pre-processing, we are doing the actual data mining task actually. So this data mining techniques, it is based on your uh, decided task actually. If you wanted, if you have an transactional data means, as that example has been taken in the lectures, which is an the transaction T1, T2, T3, and each transaction there are multiple items has been purchased by particular user, right? T2 transaction, there are multiple items has been purchased, which is an milk, bread, or along with the bread they have bought as an egg as well. So these are the transactions are there. So based on this data, you have to decide what you wanted to do with this data. You wanted to recommend something, means after buying the user has bought this milk and bread, so what is the possibility he can buy an egg, right? So this is an one way to find patterns from the data, right? So that can be helpful to e-commerce data. So based on that, suppose the users has buy this, then possibility he can buy another product. So based on that, you can manage your products, and also you can use these things to recommend the products as well, right? If you buy this, or this can be applied for the Netflix as well. If you watch two horror movies, right, and what is the possibility to can watch the another horror movie which is related to that particular uh, two movies, right? So this is a basic mathematical the techniques we have discussed in the lecture, that is an association rules. You have a transaction data, and from this transaction you wanted to find what is the confidence. The reason two terminologies are there that we have discussed in the association rules. That is an, what is the confidence score, and what is the support means how frequently those products has been purchased. So how frequently means how much time the eggs has been purchased, how much time egg with the bread has been purchased. So this is an a support, that the frequency of that particular product we are calculating, that is an combination of the products we are calculating, which is an we are calling as a support, right? And there is an confidence means what, suppose I'm uh, buying a milk with the bread, right? And what is the possibility he can buy a egg, right? So the support means that we have how much time the milk, bread, and egg together has purchased in the whole of the transactions, right? Divided by total number of transactions. Suppose 10 transactions has been done. So based on this, how much time is, suppose this is an three times has been purchased together. So this is how we are calculating the support, right? And the confidence is that it's not about this association rules. It's not about only the frequency. It is also about the association between this input data. Input means that is an you have already purchased, and this is an recommendation or what association of this particular product with this already purchased. So you are finding the what is the association in between this x and y. This is an x and y, right? So in the confidence, what we are exactly we are doing, that is an so how much time the milk, bread, and eat together has been purchased based on only the milk and bread purchased, right? This is an confidence score that we are getting from the association rules, right? Right. So there is one issue in the association rule. As second, what is the problem in the association rule? Anyone? Suppose let's take as an we have a product A, B, B, C, D up to 1000. So what? So these are the list of the unique products which has been already incidented in the transactions. So what is the problem we are facing in the association rules? Computational complexity, right? There is the cost of the computational is very high, because so you are not only finding the association rule or association in between the milk and bread and e, right? You are finding the association in between the multiple possible combinations of the products. It's not only the milk and bread, let's take as in milk and bread, there are multiple combinations are there, right? So let's suppose how much b with the a with the b is purchased, b with the c is purchased, c with the d is purchased, right? And then a b and then c, how much? So there are multiple combinations are there for the 1000 uh, products, right? So yeah, many students has given that too many rules, low support, high latency, computational complexity. Yeah. So that is a huge computational task we have to do here. So to overcome to this problem, there is one another algorithm has been designed based on this association rules, which is an a priori algorithm. Okay. So in this a priori algorithm, what we are exactly doing? So there are multiple combinations are there, right? So let's remind that or recall that particular tree structure has been designed, right? So maybe I will erase this, and so this is the last we are only recalling, then we'll directly jump to the questions, and their answer we'll discuss, and while answering those questions we'll also deepen into the concepts. Okay. So yeah, there is a multiple tree structure we have designed, right? The a b c d, and there a b and uh, b c c d, right? So there is another a b c, and so there are multiple combinations are there. So in a priori, what we are reducing the so first task is to find the frequent items which has been discussed, right? Identify frequent item set. So for finding the frequently item set, we have to go through the all of the transactions, right? So that is an also computational very costly, right? So what we are in the a priori algorithm, what exactly it does, it is removing some subset of the combinations. If a and b, this combination is not incident or occurred in the whole set of the transactions, then whatever the abc superset, we have to remove from this frequently item set. So we have to only see this set of the data for the finding the association rules. Okay. Likewise, the a priori algorithm it works actually, right? Creating the possible item groups, then removing the infrequent. These are the infrequent items groups are there. So we are removing this infrequent items, then generating the association rules in between these only frequently items groups. Okay. And based on that we are finding the support and confidence, the all the process remaining process is same. Okay. Yeah. So I think I hope you guys recall it um, uh, in better way. If you have any doubts, you can ask. Okay, let's move to the another that is let's move to the questions directly. So these questions, please give your careful attention here for this question. In this question or answering this question, this will be helpful to solve your current assignment questions as well. Okay. Yeah. So the first question is that already some students has already answered. So Yeah, that is,
B, B, sir.
yeah, this is a very trivial answer. It,
Pre-processing.
yeah, pre-processing, that is a correct option. The earliest step in the data mining process is usually the pre-processing, modeling, deployment, and visualizations. So we have seen that pre-processing steps means the KDD process, that is in data mining process, where we are storing, retrieving the data in the data warehouse, then we are doing a pre-processing, right? Then we are uh, doing a transformation, right? Then we are doing data mining techniques, we are applying it, and then visualization, right? The last is an visualization, and the it is retrieving and then processing, right? So this is the whole process that we have already discussed in the lecture as well and here as well. Okay, let's move to the another question.
So can't we visualize the data after pre-processing just to know outliers and everything?
Yeah, so here, yeah, that is a part of the visualization that we can use. The visualization, why we have to visualize, uh, is necessity, so that in the pre-processing, visualization is an what we can say, it's a not mandatory, it's based on your task actually. Okay, if you can use the visualization to identify the outliers or identify anything that you have to reduce that data, that is your choice actually. But visualization after the modeling, that is a necessary step in the data mining process, because visualization gives you insights from the data, what is the trend it's following in the historical data. Right. Let's take as an COVID-19 data. If you have a corona data set, in that you can see. So if the oxygen is beds are available, so what is the number of mm, the users who are utilizing that the oxygen and the beds. If the oxygen is high and the beds are less, the what exactly the problems we are identified in the historical data, right? If the let's take as an the mm, the oxygen plant is very far from the region, what exactly situation we have identified in the that particular region, so that findings or that insights you can find better way in the visualization side. So apart from the numerical, if you have any various numerical data, or you have, suppose you did the regression task. Okay, let's take as an one example. And so you have a data like this way, this is a historical data. Okay, and you have learned, you have designed a data mining technique, which is a mathematical model. So that mathematical model which has which is represents this data in a single line. So this line will better way to represent this data, this is an historical data. Okay, and this is our data mining uh, mathematical uh, mathematical formulation, we can say. By using this mathematical formulation, can we forecast, can we identify unknown values? So this is an x values and this is an y values. So this x and y values, we don't have an historical data of that x and y. Suppose if we have in the future time, if we have x and y which is not in historical data, can we predict that particular value? So we can predict that particular value by using this line, right? So in this line, this might be a value. So this is a multiple values we are getting for multiple x and y's, right? Multiple x and y's. So if you manually do identifying these values, it is a very tremendous task. You can directly plot it here, and you can relatively map that, oh, these values for the x and for this y region value, for this x value might be this, these regions are these values we are getting. So this is the what we can say, this is the efficiency of the visualization actually, that is helpful for these visualization. So this is one example. So there are a lot of examples can be considered for the visualization to get the novel or to get a non-trivial patterns or non-trivial insights from the data, historical data. So the visualization will help in that case. Okay. Yeah, I hope this has been understood, that why we require the visualization after the doing the modeling task. Okay. So you can do as well, but that is not might not give a uh, so this line is an data mining formulation, right? So this will not get you will get as an in the pre-processing state. After the pre-processing, after the data mining, you will get this formulation, right? Then you can better represent this visualize the data, and you can get insights from the or patterns from the data. Yeah, so already that is a process of, so that is required actually. Means it's based on your application, what exactly the application you are addressing. So that already includes in the what we can say, already includes in the data pre-processing. But the data visualization, it requires, it's not necessary actually. You can also get outliers by analyzing the data. Then so if you're, yes, I don't know, some students are raising the hands, but yeah. These are already giving the answers for the next questions. Yeah. So yeah, the outliers you can remove that. That definitely the affect to the mathematical formulation that you are modeling. Sometimes that is required. The outliers may be required for the some specific task. Suppose it is an X-ray data, and you wanted to find a that is a cancer X-ray or not. Right? So for that you have to consider multiple, you have to consider multiple passengers, multiple sorry, multiple mm, users who has an outlier. Might be those users has an that is an diabetic patient, and that's X-ray is different from the other normal users. So these outliers you have to also consider while uh, some of the application. This is an task dependent actually. Okay. So let's jump to the question two. Which of the following is an example of continuous attribute? Yeah, that is a very trivial answer of this. So this is an name. It's not as an it is a person. It's not already stated. It is an nominal data attribute actually, which is a not comparable in between them, and it is an character data. The continuous is an the point one, point two, point two, point three, likewise. Okay. Gender is an binary, zero or binary, or there is a distinct, I mean, 0, 1, 2, 3. Okay. And the height might be there is, this is an the continuous value. So the option A is correct here. 1 second. Sorry. Yeah. So in question 3, the which is a friendship structure, already discussed this answer. So what could be the answer for this question? The friendship structure of users in a social networking site can be considered as an example of which? The C, option C, which is an graph data. Might be some student has not understand. I will like repeat that and visualize, try to visualize uh, how could be this representation structure is an graph. So let's take as an we have a graph which is an a user with ages E. V represents here as user, and E represents here is and for friendship relationship. Friendship. These two nodes means, or vertex means, that is an user, distinct users. These two users are connected if they are friends to each other. Okay, likewise. So these nodes are connected if they are friends to each other. Likewise, so so this is how this structure is represented in a graphical structure. So that's why we are calling as an okay. Yeah, I hope you guys understood till now. So for this question, what could be the answer? Already discussed actually. Yes, nominal. And why is it so? Why is it nominal? Yeah, no comparable, non-comparable, simply right. So nominal is signed only the identifiers. So the already examples has, and suppose the bank data, bank transaction data. So each object has an one attribute which is an account number. So account number is not comparable to each users, right? It's this account is greater than or richer than this users. It's based on the account number we can judge that, right? So only that is an identifier, or name. If it is a name, that is only an identifier. Ordinal, that might be a, that is uncomparable. Let's take as an balance of that particular account. There are multiple accounts are there, and each account there is an balance attribute is there, and each balance there is an how much balance is it. Based on this balance, you can might be judge that the particular user is an reach or not by comparing the each other, right? So that is an ordinal. Interval that I already mentioned, that is in period. Ratio is, it is an free values. Okay. Okay, let's move to the another question. So what is the answer for this question? Yes, anyone? Yeah, B. Yeah, 15C2, that we have to do a combinations, right? Multiple combinations are there. 15C2, how we are calculating this? 15C2, 15C2, that is in 15 into 14 divided by 2 into 1. So this one is an to 10 into 2, right? 105. Right. I hope you guys understood. So if anyone is not understanding anything, any silly questions, let me know. Yeah, Shreya, go ahead.
Sir, I wanted to ask what is here meant by number of candidates to item sets is.
Okay, yeah.
I couldn't understand.
So yeah. So if any silly questions or any questions, that is, this is not silly, but it's fine. But if any difficult to understand the question, please let me know in that case. Okay. Yeah, where we are.
Sir,
So Max, yes.
sir, can you just elaborate on that ratio and interval, sir? That attribute types.
Yeah, sure, sure. So the interval means that you are specifying some periods actually. Period means that is on a particular date. As already given one example, that suppose you have a product data, a product 1, product 2, product 3, and each product has some specific attributes are there. So let's take as an interval attribute, that is an one attribute which is an best offer. The best offer one, let's take it, best offer. So this is one attribute, and in this attribute it is mentioned some dates actually. So on the 5th of Jan, this is an, this product has offer some offers. On 26th of Jan, this is an 26th of Jan, this has an some offers. So this represents the this attribute as an interval attribute, right? It might be a certain period. So 26 to 29, it is an that this product is valid for the offers, right? Likewise, the ratio means that is a free value. There is a no range in between them actually. That could be anything, any values are there in the ratio. So that is an let's take as an the value of that particular ratio. The value, that means suppose that is an 500, 526. So there is a no range in between them, right? So it represents as an the ratio attribute, right?
Sir,
I will,
any real world examples for ratio?
so the real world example, the same here, that is an product. For each product, there is an separate values are there, separate amount is there. Likewise,
So
suppose
is it similar to nominal values? And I'm getting confused between nominal and ratio.
no. The
So even
nominal is
both.
identifier. The nominal means, let's take in this product, in this example, the nominal attribute could be is the name of that particular product. Let's take as an the wireless boat wireless earbuds.
Okay.
So this is a name that can be comparable to the other product,
Yeah.
right? It's not as
Yeah.
an it's greater than to product to by using this name, right? So that is a nominal, that is not
Okay.
comparable to each other, right? That
Okay.
is an identifier of that particular product. You're getting?
Okay.
Yeah.
Yeah. Yes.
Yeah. So let's, yeah, here the maximum possible number of candidates and two item sets. So the let's I will explain the question here. What exactly the store sells the items? Sells the items means a store has a multiple items are there. Might be greater than 15 items are there. 30. Let's take as an example. 30 items are there for this store. Okay, and from this, out of these 30 items, there is a transaction data of this particular store A. Okay, transaction data means, let's assume as an one table, that's a T1 transaction, T2 transaction, T2 T3 transaction, and each of transaction there is a has been some items has been purchased, right? So some transactions has been only the milk and bread, some transaction has been bought a charger and uh, something charger and mobile. Okay, so this is a combination, and this our whatever the products has been incident in this transaction, those products are, those items are 15 only. Are you getting? Means this 15 items has been only purchased in this transaction table. Okay, so that's why it is mentioned that a store sells 15 items. Okay, 15 items has been bought by the users. Okay, so out of these 15 items, the maximum possible number of candidates means the possible number of what we can say, possible number of items, candidate items. So okay, let's take as an example. uh, 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 so here, so okay. So we have a 15 items, right? 15 item includes A, B, C, D. These are the item names we can call right now, and up to 15th, right? Sorry, 15th. So the maximum number of combinations, it is saying then possible number of candidates means how many candidates, how many combinations will be uh, done for this particular, one second, yeah, how many combinations in between these 15 products. And those combination is not only the three combinations or fourth combination. We wanted the combination between the only two items are there in that particular combinations. Means the two set of the combinations means A and B. This is one combinations set. That is in B and C, and then C and D. This is a two set of the combination, right? Two items, their combinations are there. So how many possible combinations are there? The length of the combination is only the two. So that the question is asking actually. The maximum possible number of candidates. These each represents, combination represents one candidate. which has an 2 item set. So this is an 2 item set. So how many we can press? So we have 15. So we have to find the multiple combination, which is, and we have seen in the probability PSQT, that in probability statistics and theory, that 15 combinations with the 2. So that we have calculated here. Yeah, might be understood, right? Possible number of subsets. Per record data matrix. What is the answer for this question? I will explain the questions again and the answer as well, but please try yourself first and then I will explain it in detail. Okay, some are saying the A, B, confused
B,
out.
sir.
B. Okay. Let's see which option is correct.
Sir,
Yes, Ravina.
I have a question in the rows represent the data points or the feature space?
Data points, which are the objects, data points, we can say that,
Okay, sir.
or records we can call it. So we have discussed the dimensionality reduction in the dimensionality reduction we have discussed as in PCA, principal component analysis, and single value decomposition. What exactly we are doing there? We are reducing the number of rows or reducing the number of columns there?
Features are columns.
Right. So that's why the B option is it's not correct here. Okay, I will explain the question here and then we'll discuss the answer in detail. Okay. So if a record data matrix has a reduced number of rows, first of all, what is an record data? That we need to understand, right? And the number of rows after a transformation. So first draw the record data. What exactly the rate of record data? I already mentioned or explained this record data, which has some rows and there is columns are there. So this is a table represents as an record data. So each row represents as an object 1, object 2, object 3. These are the rows. Okay. And each object which has a respective attributes. So attribute 1, attribute 2, and so on. Okay, these are the columns. Okay. So here the question is asking that the record data matrix, this is a matrix, rows into columns. Okay. Matrix has reduced the number of rows. Number of rows, it is saying. Number of rows need to reduce it. Reduce after a transformation. Means there is an, in the KDD process, knowledge discovery in database, we have seen there are multiple steps: pre-processing, transformation, data mining techniques, visualization. In the transformation step, we are reducing the rows, and after this transformation, means what, which technique we are performed so that it reduce the rows from the record data, record data matrix. Second, some students are right. Okay. So in data sampling, let's discuss about the, because option A is saying right now most of the students are correct, but other than this option, let's see what the other options are meaning. So districtization. So I have given one example that we have a attribute which is an continuous, and we have to uh, transform these continuous values into a binary values. That I have given one example that a particular range of age we have specifying this is a category of younger users, younger passenger. uh, Range of the age in between the 18 to 20, 30 is an adult users, or other than this or older, maybe, that we can say. This is an potential example I have given, it's not true in the real world. Okay, so this is an districtization. It is not removing some rows or columns. Okay, only it is transforming continuous values to district values. Getting distinct values means it is giving some categories to data. Cleaning. Noise cleaning, it includes there is a suppose a missing values, okay, or there is an outlier that you can remove it based on your application or task. Another is an suppose there is an missing values, if there is a age is not mentioned or any attribute is not mentioned, so you can consider it is and that particular value you can fill by the mean of that particular column attribute, or you can simply analyze that what value we can put there. That is, and only you are filling the misvalues, not is and reducing the rows and the columns, right? So this is that part. Data dimensionality reduction. Dimensionality reduction in it is about the feature attributes. It is about the columns. There are suppose 1000 columns are there, 1000 attributes are there, and from these 1000 attributes there are only few attributes which are required or which are important for our particular task. So whatever we are doing to reduce these attributes, or we are selecting the important attributes, that is including the dimensionality reduction. That PCA or single value decomposition will give important features, or will reduce the columns attributes. So 1000 to 50 based on your, that is an hyper parameter. If you wanted to give 50, that will give a 50, okay. So 10, 20, 30, so 1000 to 30 features you can reduce, that is a column you are reducing, that is included in a dimensionality reduction, which is about the columns. And in data sampling, what you are, which is about a rows, you are only selecting or retrieving a particular data only. Suppose there is a time series data you wanted to see, suppose an time series data from the 2015 to 2025, and if you wanted to analyze or find the patterns about the COVID-19, then you have to only consider the 2019 to 2021 data, right? So you can see, you can imagine that there is an 2000 to 2015 to 2025 lot of data records are there, and you are only selecting subset of the data which is for ranging from 2019 to 2021 to analyze, to find the patterns about the COVID-19. So that is an data sampling apart. You are sampling the some data, right? There are multiple ways you can sample the data, that is a random sampling data or range sampling data, okay. I hope you guys understood. Yes, okay. Let's move to the another set of the questions. So this is an very, these questions are calculating questions, means you have to calculate some values here, okay. So by watching this as of now till this slides, you might be learn that what exactly the record data, what is an order data, what is an graph data. So after watching this data, what do you think that which this data is for, fall into which data type? It is a record data, graph data, or ordinal data? Yes, it is a record data. Yeah. So here the customer ID is there. So each user, each customer, there is an unique ID, distinct ID is there. And each user, each customer has done multiple transactions means yesterday he went there, that particular user one, and he has purchased, he has done a transaction and he purchased ADE, three products. These are the items that particular product has buy, that user has bought. In today he also went that particular store and he made a second transaction, and in this second transaction he also buy A, B, C, E, these three products. So this is how the record data represented here. Okay. Right. So I hope you might be understood how this data is represented here. Okay. Mm. Hmm. So based on this data, we have to solve the below question 7 to question 10 questions. Okay. Okay. So first read the question and please try to answer this question. Just try to solve this question. If you are not able to solve, don't worry. I will also explain this question and answer. Take 2 minutes and please try to solve this question. Yes, till now, is there any doubts? Please recall this. What is the support we are calculating? How we are calculating the support? There is a two terminology we have seen in the association. The first is the support, how frequently that particular product or combination of the product has been bought, and the confidence, that is and depends on you have based on the X, what is the probability or likelihood you will buy a Y factor, Y items, that is in confidence. So here you can recall that how we are calculating the support. Yes. Oh, so this is very important. How I can you take a photo of this slide that will be required for further questions. Okay. Okay, so can you show it? Yes, have you taken this photo of this slide? That will be helpful for to solve the questions. Yes, Shreya, you want to say something? Yeah, okay. Yeah. Okay, so might be, yeah, someone has given the answer A 0.8.2.2. Let's take as let's see if it is incorrect or not. We need to solve this question. Yeah. So here we have let's see, someone has got as an yeah, it's not as an issue, that is an that might be a answer, that someone has given an D option. Let's see which option is correct or not. 100. See, 100 means very extreme case. Okay, E has been, there is one case the E is not occurred in the fourth customer, so there is no possibility get as an E support value is an 1. Okay, yeah. So what exactly the support is? The support we are calculating. So for each item set, we are calculating their support. So we have item set is an E. This is an one item set has been given. That is an we can call as an candidate, one candidate item. Another is an B and D, and another is an B, D, E. Okay. So support means we have to find the what is the frequency or what is the occurrence of E product. Okay, occurrence of E product. Sorry, small divided by total transactions. Same with this B and D occurrence and the total transaction. Same with this B, D and E and their total transactions. So let's find occurrence of E. In the first transaction, E has been identified. This is for the E. Identified. This is there. E is there. One E is there. E is there. E is there. Yeah. E is not there. You can see here E is not there. So that's why it is 0. E is not there. E is here. You can see here. E is here. 1. So how much it is? And 8. We are getting as an 8 value, right? And total we have 10, right? So for this we are getting as in 0.8. So directly the first option is there. But for the let's also check for point 2 and point 2 is correct or not. Okay, point 2 and point correct and not. So B and D we need to check. B and D. So B and D. So here B is not current. B and D is not simultaneously purchased. B and D simultaneously purchased here. So that's B and D is not. So here is also not B and D is not purchased. Here is purchased. Here 0, 0, 0, 0. So only 2 we are getting here. The 2 divided by 10, that is an 0.8. Sorry, point 0.2. Okay, so BDE. For the BDE, let's take as in check BDE. It is not, BD is not, this is not, this is BDE. 2 is continuous. This is not. Because you can directly make 0 here because already B and D is a subset of the BDE, right? If the BD is not present, then the BD superset is also 0, right? That's why I'm giving as in 0 here. If it is 1, then we have to carefully see if it is E or not. Then along with the B and D, there is an E or not. So here B and D 1. So other is 0 directly. Right. So we have 2, that is an 0.2. So this option is correct. Is there any doubt or any confusion while solving this question? Okay, if not, let's move to the another question. Yeah, so based on the results in 7, so in 7 we have calculated the support score, support values of the rules has been given, and here we have to calculate the confidence of association rules. The association rules has been mentioned here. Okay, these 2 association rules. Yeah, so what could be the answer for this question? Please try to solve. What is the, please recall that how the confidence we are calculating. I will give for the simplicity how the confidence will be calculated. So let's take for the transaction 1 T1 how the confidence we are calculating. So this is the frequency of B, D, and E you have to consider divided by that is an given BD. What is the possibility you will get as an E as well, right? So only the B and D you have to consider. So only given by purchasing only B and D, what is the likelihood to purchase along with the B and D, likelihood of the E product along with the B and D. So this is the formulation of the confidence value. Please try to solve. So here B and D we have already calculated, and B and D E also we have calculated what is the value. So is anyone have got the answer? Very simple. The BDE we got C A B. Okay, so many different answers we are getting. No worries. This is the chance you have to clear your doubts actually, right? Yeah, someone has given the B. Majority has given the B. B. Yeah, no issue. Who has given the wrong answer? I don't know which one is the wrong and correct, but some users, some students might has the wrong answer, right? Because the B and C, both time the B, C, A, B, C is not correct, right? Sir, how this is done? Please tell again. Tell. How this is done? Yes, yes. I will explain the question and the answer as well. Okay, no worries. Okay, so the question is asking what is the confidence score of given association rules. So there has been given some rules. The two rules has been given. The first rule: if the person has buy or bought B and D, what is the likelihood to buy a E? So this is the one rule has been given. So for this rule, we have to find the confidence score. Confidence score means that will give a likelihood of that particular product. So after buying the B and D, what is the likelihood of E? That gives a confidence score. Then another rule: after buying or purchasing E product, what is the likelihood to purchase a B and D along with the E product? So to get the confidence of this particular rules, there is a formulation has been. So this is we need to get a frequency of B and D, E are simultaneously has been purchased. How many times B, D, E simultaneously purchased in the transactions divided by frequency of B and D. These two products are simultaneously purchased. So we have already seen that. Let's take as an let's find the occurrence values of this BDE. So we have see the BDE occurrence value is 1, 1, 2, and BD is in 1 and 1. So this is 2, this is 2, this is 8. Right, occurrences values. So directly you can put here the occurrences values 2 divided by 2, right? That we are getting an 1. Here the option B is correct, but let's see the other rule confidence score is correct or not. Okay, might be. So there is some cases there might be a second option might be means in the from the answer the option might not be correct, right? So yeah. So for transaction 2 or rule 2, so there is an BDE same because same combination is there, but in the denominator only E is there because by purchasing D, this is a historical data. Purchasing D, what is the likelihood of the BD? So BDE already know the values and the E occurrence is 8 here, right? So you can directly put here 8 and you will get as an 0.25, right? So the option B is correct. Any doubt or any query? Yes, the recording of this session will be make available on uh, the course site that you have a you are able to see your week wise videos, right? The appropriate video and the assignment. The below of that you will get a the link actually in next week maybe or 2-3 days. Near accurate. Not getting Jagan. Can you please elaborate that? What do you mean by? I mean, so what exactly you are saying?
Yes, sir. I hope you can hear me. So I'm just trying to understand how do I know whether this formula of this confidence, right? Can I really trust upon that? Is this? I don't understand the background of this formula, and that's why I'm asking.
Oh, okay, okay. So here, whatever I'm explaining, I'm assuming that you have watched all the videos has been provided in the week V, and here I'm only recalling some concepts or giving some overview. So that's why
Oh,
I assume that this has been clear how this formula has been evolved.
okay. Sorry,
No issue. I will
I got.
explain it again here.
Yeah, yeah.
Okay. So,
I will go through, sir. No problem. Thank you.
okay, no issue. Thank you. Yeah. So, is there any other doubts? Yeah, I will provide my mail ID. So already in the first slide, I will show at the end of this session, I will show the first slide over there. The mail ID has been written. Okay. Is there any another doubts while calculating the confidence score? Okay, no issue. Let's move ahead. Okay, please read this. Only the last two questions are remaining. Okay, after that we'll free. Okay. Yeah. So please read this question carefully and please try to solve this question. And yeah, I will also explain this question and the answer, but please try yourself first and then we can discuss it over. Okay. If you have already calculated and already understood the support and the confidence, then you will easily solve this question easily. Okay. B. Yes, anyone? Carefully see, the question is a little bit different than the previous one, but the main core of this core to understand this or address this question is similar to previous questions. Okay, only little change in this, which is an by taking customer ID. That is an different question. That is a difference between the question actually. Okay, let it be C. Someone is saying the B and some students are saying the no worries. Yeah, let me find which option is correct. Okay, so I will write first question here. Question 9 repeats question number 7 by taking customer ID as market basket. Okay, here the customer ID, previously we are considering a transaction ID as a market basket, that is in one basket, right? Here we have to consider a customer ID and there is a multiple customer IDs by many transactions, means each customer IDs, let's take as an, okay, I will show here. So you can see here there are multiple customer IDs there and which has which has done the multiple transactions. So in previous question, in question 7 and question 8, we have considered a market basket. So sorry, sorry for the that. Okay, here the market basket we have considered in previous questions, which are for the respective transaction IDs. Means for transaction ID 1, there is a separate market basket. Means only we have considered ADE has been purchased in the single. In transaction 2, that is a separate market basket we have considered. Likewise. But the question 9 is stating that you have to consider customer ID as an market basket. So here the customer ID is 2 times is getting. So we have to consider this is one single market basket for the customer ID for this transaction. So this customer ID 1 market basket is considered as ADEBC. So I have taken a distinct values here, ADE and B and C. Right. So this is the one market basket. Considering this, you have to make a table, another table. Okay. So for this is a one market basket. This is single one market basket. This is single market basket. Considering this, we have to solve the question. Okay. Okay. So what the question wants? Let's see. The customer ID as a market basket. As an item is treated as one if it appears in at least one transaction done by customer, that we have already discussed, right? An item is treated, I will repeat this sentence, item is treated as one, that is mean that is purchased if it appears at least one transaction done by the customer, otherwise zero. If it is not uh, incident in their all the transaction of a particular customer, then it is a zero, right? So here, sorry, here A B C D E, A B C D E, all are done, but some transactions, here you can see in this fourth transaction, the fourth customer, that uh, A, B, C, D only are there. Means these are the only one, and E is zero because E is not purchased by the customer ID 4. Right. I hope you have understood how to map with the customer ID here. So if you are successfully mapped this, then you can easily solve this question. That is an we are simply calculating the support and the confidence score. Okay, let's take as an this rule for this. Let's for the item set E. So what is the frequency or occurrence of the E divided by total number of transactions? Okay, here total number of transactions means how many unique customer IDs are there. Okay, you can see here total number of the five are the total number of transactions we are considering here. So let's find the how many occurrences of E is there here. One, let's write it here, A, B, C, D, E, or B, C, D, E, 2, 3, 4, 5, and A, B, D, E. Okay, I will erase this so we can write these updated values here for each transactions here we are considering as a customer ID. Okay. Okay, so first we are finding the E. E is present, yes, E is present, E is present, E is present here, E is not present here, E is present. So out of 5, only 4 E has bought actually. So here you can see the E will be the 4 and the T will be the 5, right? So what am I? 5, 7.8. Yeah, right. So the from this, which there is might be from this there might be one case actually. Okay, someone has already given the combinations there in the comment box. Let it be, but I will calculate it again so my some student might be understand. Okay, so we have to find the B and D together has been bought. So let's find here BD and BDE. The two things are there. So B and D, yes, B and D is bought it. B and D is purchased here. B and D purchased here. B and D purchased here, right? BDE. BDE is purchased. BDE. Here you wanted to only see the E is purchased or not. E is purchased. E is not purchased. You can see by using this, E is not purchased, so E automatically is 0. Right? BD is not purchased. So here. So that's why the values are here. That is 5 divided by 5. Then another is and BDE. So for this, the occurrence is BDE is all the transactions. So 4, 5, it is and 1 is and 0.8. So the option D is correct. Yeah. Might be you guys understood right now. This is a customer transactions. Customer.
Yes, sir.
Yeah. Yeah. Is there any doubts while getting the numbers? Okay. If not, let's move to the last question. So this is an that further connected question actually. So here, then in this question, we have calculated the support, right? Here we calculated support for the item sets, these 3 item sets. Right now, we have to calculate the confidence of association rules. Okay. So based on the results in 9, the confidence of association rules, BD, given BD, what is the likelihood of E product, and given purchased E, what is the likelihood to purchase BD along with E? Okay. So here I will write a formulation for these rules, the rule 1 and rule 2, the confidence score. Here the confidence score is right, and we have to get the occurrences of BDE, right, already calculated in previous question, and the occurrence of B and D, right. This is an given confidence score. So this is an confidence score of BD, occurrences of BDE, and denominator the confidence of the given E. This is the E we are setting. Means by purchasing the E, what is the possibility to purchase the B and D along with the E? So that's why we are putting it that E factor in the denominator. So what is the answer for this question? Have you tried to solve this question? Okay, some students are stating that it is an A. Okay, let's check it is an A or not. So BDE, what is the occurrence score we are finding? BD is an 4, right? And the BD is an 5. Oh, 5. So we are getting as an 0.8 here. So that is exactly the point. A is option correct, but let's try to find the value for the rule 2 confidence score. The BD is 4, E is an E. What is the E value here? E value is also 4 here, right? So the A4 is there, so 1 we are getting here. Yes, I hope you guys understood whatever we have taught in this question in this session. If you have
Yes,
any
sir.
doubt,
No, sir.
if you have any doubts or any queries, which might be silly or any doubts, you feel free to answer, raise your queries here. If not, then no, we can stop this session. Before that, I will show my email ID. This is my email ID, mane.1@iitj.ac.in. Right. And in between the week, if you find any queries or any difficult to understand anything, please write me an email. Okay. So I'll try to answer by the email, or we'll cover that particular thing in the next session. Okay.
Thank you, sir.
Thank you. Yeah, thank you for the listening the session and attending the session. I hope you will also guys attend the next session, and we'll have interaction in the second session. So this is a two-way interaction. So I'm trying to discuss with you other than the only discussing me throughout the session. Okay. Yeah. So yeah, nice to talk with you. Thank you. Thank you so much. Yeah. You may leave this session. Bye. Good night. Yes, Raghu. You wanted to say something? Okay. If not, please, you may leave this session. Thank you. Some students are joining now. What should we do? Okay, let it be.